Thank you. Hello, my name is Chi from Argus Media. I'm the editor for Argus Media, overlooking Asia's metal coverage. Delighted to be here, and thank you very much for Petrominda for inviting me to talk about nickel and cobalt. Next one, please. Next one. Yes, so let me start with a quick, very quick summary or introduction of Argus for those who don't know who we are. Argus is a leading price reporting agency. We provide market intelligence and pricing to many sectors, including energy, fertilizers, chemicals, energy transition, agricultural, and of course, metals. Outside of our price reporting services, we also have a consulting arm. So actually, the data that we use in this presentation are actually jointly prepared by myself and my colleagues in the consulting department. I think that's enough of Argus. If you want to know more about Argus, please come and talk to me afterwards or my colleague, Frank. Thank you. Next one, please. Okay. I don't think I have to spend too much time talking about EV forecasts, as I'm sure that you have heard a lot already today, and you're probably going to hear a lot more later on. So in a nutshell, at Argus, we forecast global EV sales to reach about 49 million units by 2033, which is a growth rate of about 13.5% or so on every year. And out of these 49 million units in 2033, about 93% of them will be battery BEVs. Next one, please. So based on the very strong growth in EV sales, it is no doubt that we can expect a very strong growth in battery demand. Which Argus, we forecast demand for battery to grow to about 2.5 tetrawatt hour by 2028 and 4.5 tetrawatt hour by 2032. We go next one, please. So based on the very strong growth in EV and sales and of course battery, we were going to need more battery metals, so nickel and cobalt in focus. Can we go to the next one, please? Thank you. So let's look at the cathode first and cathode demand in general. Total demand for cathode by weight is likely going to rise to about 8 million tons or nearly 8 million tons or so by 2033 or in the next decade, which means that we're going to need about 3 million tons more of these battery material in the next 10 years or so. As in the past year, 2022, 2023 or so, we used about 5 million tons of them or so. As a result, nickel obviously is one of them and is going to be seeing very strong growth. So we expect demand for nickel from all usage, including battery, stainless, and of course many others usage as well, to grow to about 4 million tons by 2033, and total cobalt demand to grow to about 255,000 tons, with EV demand likely to peak in 2017 at about just below 100,000 tons. Next one, please. Nickel, looking more at nickel in focus. Obviously, for nickel, stainless steel is going to continue to dominate demand for nickel, but EV applications or battery applications are going to grow to a larger share, much larger share actually. We expect stainless steel demand for nickel to see very moderate growth in the coming years, rising to only about 2.3 million tons or so in 2033 from the current state of about 2 million tons or so. This is because of a combination of reasons or factors. For example, a more stagnant stainless steel demand growth because of recession and economy and so on. And also, quite importantly, is the fact that some stainless steel makers or the stainless steel industry are actually moving away or trying to develop stainless steel that are using less nickel or even no nickel content. But EV demand for nickel, on the other hand, will continue to grow and grow at quite a good rate as well. Although this rate is likely going to be, it may possibly be at a slower pace compared to what we have seen in the past few years, which was pretty much ballooning and growing at a very fast rate. Growth of this growth of nickel demand will typically coming from the transition within the NMC chemistries. So nickel, cobalt, nickel, manganese, cobalt chemistries. So that chemistries is going to industries moving towards using higher nickel content chemistries. But the rise in the influence of the nickel-free LFP is potentially flattering the curve a little bit. We expect that EV demand for nickel to grow to about 1.2 million tons by 2033, which is going to account for over a quarter of global demand. If you compare to that now, that's quite a big growth in terms of market share. Well, on the supply side, global refined nickel capacity was around 4 million ton or so in 2022, and we do not expect there's going to be a very strong growth in capacity. The nickel sulfate project, I expect us to add at least about 200,000 tons or so per year of output in the coming years, while there's also a few new nickel and cobalt mines coming up online in the coming years. Next one, please. Cobalt, another battery metal. Cobalt is typically used in NMC, but the industry is actually moving away, or the battery industry is actually moving away from cobalt heavy NMC because of various reasons, for example, cost, performance, and I think quite importantly, ESG concerns as well. Global production was around 160,000 tons or so last year of cobalt, and we expect that to double or to grow to about 320,000 tons or so in the next 10 years. But we expect that mined output are going to peak in late 2020s and decline after that because miners are going to try to avoid a price crashing surplus. And one of the main reasons that I believe that is going to have to help to increase the supply of cobalt without a mined product is recycling. Cobalt is actually a very relatively easy product to recycle, metal to recycle compared to a lot of the others battery materials, and its recycle rate could reach as high as or even over 90% in the next 10 years or so as technology advances and the product become increasingly commercialized. Next one, please. So we now know that we need more nickel and cobalt. So where are we going to find them? Most of the new projects are going to be based in Indonesia, as we have heard today already, and Australia. There will be a few in Australia as well for both nickel and cobalt. Traditional mining base for cobalt, such as DRC, they're going to have a few new mines, along with new mines coming up in Chile, the US, and Canada. The next one, please. If we can skip one. There you go. Thank you. So we look at the refined supply or refined output. Asia is going to remain the dominating state, particularly China, as China will likely to remain the key refined nickel and cobalt supply in the coming years. But we have seen today that, as countries that are mineral rich, such as Indonesia, are moving further downstreams, and I think a lot of other countries are following what Indonesia has done of moving the industry further downstream to try to create a supply chain that has produced more value-added products. So we will probably see more refined capacity in these mineral-rich countries such as Indonesia, Australia, or even Africa. We have also seen increased investment to refine facilities in other regions that are less mineral rich, such as Japan, US, Canada, or even Europe, because a lot of companies are trying to move away, or at least to move certain parts of their supply chain outside of China. But at the same time, China, which is not mineral rich or not rich in these kind of minerals, comparing to Indonesia, Australia, they're increasing a lot of their overseas investments. This is probably a preparation for any disruptions or any drop in seaborne ore availability. As we have seen in the past slide, that there were quite a few Chinese companies, and I think we all know that there's quite a few Chinese companies having new facilities or new sites in Indonesia as well. Next one, please. And as I mentioned earlier, that recycling is likely going to play an integral part of the battery supply chain in the coming years. Let's not forget one thing, that nickel and cobalt are actually very much recyclable nowadays already, in terms of both technology and in terms of commercial, which is unlike lithium, another critical battery material. Actually, we have seen over the past few months or past couple of years that there's been a flurry of interest from multinational companies or investments into commercializing the recycled products. For example, we have Glencore setting up sites in North Africa, and Lee Cycle setting up sites in the US. So with the processing of nickel and cobalt from battery waste or black mass becoming increasingly established, we expect that supply from recycled batteries to rise to about 35% and 14% of demand by 2033. Of course, this is only talking about battery recycling. If we look at recycling of cobalt and nickel from all usage, for example, stainless steel and other applications, then the portion of supply is going to be even larger. Next one, please. We look at that by 2033, recycled metal as a percentage of demand could reach as high as 60% and 90% for nickel and cobalt, respectively. And I feel that the future, and I strongly feel that the future recycling rate of cobalt is particularly important and particularly interesting to the industry, because of the strong recycling rate. There is even a situation that we may not even need virgin material. Just supply from the recycled cobalt is entirely enough to meet demand for cobalt, which certainly is going to pose threat to virgin supply and questions to current miner and new coming miners. Next one, please. So now, as a PRA, we have to look at prices. So how are these changes in the supply chain are impacting prices? Next one, please. So Class 2 nickel, which is, of course, at the center on the spotlight of the nickel industry at the moment, and the battery industry, has been mostly traded at a discount to LME prices, which is traditionally the benchmark for nickel. We have seen that now we're looking at around 60%, 65, 70% or so NPI as a percentage to LME prices. So traditionally, the per nickel price in LME, the per nickel content price in NPI, for example, is typically around 100% of LME prices, because we're pricing both. Because in NPI, we're also pricing it in per nickel content. Which effectively this means that there's traditionally no difference between the nickel in the NPI and the nickel in the cathode. But this has changed over the past couple of years. The value of nickel in NPI, we have now seen, and several other Class 2 material have dropped compared to the LME benchmark. I think there's a combination of factors. I think it's a combination of factors for that, because there's increased supply of Class 2, obviously, and the fact that Class 2 is becoming more and more widely traded, particularly on the seaborne market. And of course, another reason is the dominance of China in the Class 2 nickel industry. So, for example, we've seen earlier that Indonesia exporting 80 to 90% or even over 90% of their material, which is typically cost to China. So when China is that dominant, there's less bargaining chips or less purchasing power or negotiation power from Indonesian miners or Indonesian smelters. Next one. And it's quite interesting that the drop of the correlation between the LME and the NPI prices actually has spilled to the recycling world as well. If we look at the stainless steel scrap, the 304 stainless steel scrap prices, and the nickel prices on the LME. The LME price has fallen by about 30% or so far this year to date, while stainless steel scrap has only fallen about 10%. So that's about 1/3 of LME movements. What this means is that this resulted that the nickel value in the 304 stainless steels, which is typically has around 8% or so of nickel, has fallen to about 60 to 70% from 110, 120% early last year. Next one, please. And of course, last but not least, we mentioned about recycling and the importance of recycling earlier. But one of the major problems that I've seen, when I'm talking to the battery makers or the battery industry, is that outside of technology, that the recycling industry and the battery industry is facing that is there's no standard. There's no standard in pricing mechanism for pricing battery waste. Everyone has different kind of battery waste. For example, your Tesla is going to have a different battery compared to your Ford, compared to your Honda, compared to your Kia. So there's all of them are called battery waste, but there's no standardized way of pricing the material or pricing the black mass of it. So at Argus, we have heard from the industry, and we are taking a very innovative approach. So we have created this black mass calculator, which basically is a tool that gives the industry more flexibility as a calculator to calculate your recycled product. We have made some pre-made chemistry, but we also allowed you to create your own or change the pre-made to suit your recycler or your black mass product better. And of course, there will also be function to allow you to add in certain costs as well. And with the vast assessments or with the vast pricing that Argus offers, you will also be able to use electricity or natural gas or any other prices that would suit your production line. If you want to know more about that, speak to myself afterwards or my colleagues. So next one, please. Thank you. Thank you very much for your time. And this is just a summary of the presentation. So the strong EV and the battery forecasts are certainly going to boost the nickel and cobalt demand. We are seeing momentum, a very strong momentum outside of China, particularly for the downstream facilities. Mineral-rich countries are certainly expanding on the downstream value supply chains. Recycling is very, very crucial to the whole industry, particularly to diverse the supply chains. But the question is always going to be how we're going to price battery scrap. And finally, there may be scope that we can adjust the current pricing mechanisms to better suit the ever-evolving industry. One of the questions that I always ask to the industry is, with the EV and aerospace demand, are they going to drive, nickel prices or class 2 prices further away from the LME or further coupling from the LME? And I think also very importantly is the industry will certainly benefit from a pricing mechanism that balance between China and non-China markets. Thank you very much.
Thank you, Chi, for your presentation. Any question for Chi? No question? I have one question for you. Okay. It's me.
I thought I was lucky.
Now, you mentioned that in your forecast for nickel demand, you mentioned that there is a declining demand for nickel due to the fact that in the stainless steel sector, there is a trend to producing no nickel products,
yes.
No nickel content. Now, this is something that is happening in the industry since many years.
Yeah.
There has been this attempt to do this, but never moved big volumes.
Yes.
So what are your expectations in terms of volumes?